Let us calculate the Fourier transform of a unit impulse pulse. The impulse pulse, as you all know, x of t is equal to del of t, and this impulse pulse will try to have a value of infinity at t is equal to 0, whose area will be equal to unity, and the pulse is said to be available only at t is equal to 0, not at all other places. According to the definition of Fourier transform, when you want to calculate Fourier transform of a signal, you have to use this formula x of t into e power minus j omega t dt. So the given signal is now del of t e power minus j omega t into dt according to the formula. It is not necessary to evaluate the signal over minus infinity to plus infinity, because the signal will exist only at t is equal to 0. At all other places del of t is equal to 0. So when I substitute t is equal to 0 into this, we'll come to know that the area under this signal will be equal to 1, and naturally e power minus j omega t will become e power 0, it is equal to 1. So this will give me the result of Fourier transform as 1 for all the values of omega. I just make it like this. If the signal is an impulse signal which will have an area is equal to unity, a small pulse whose area is equal to unity, which is available only at t is equal to 0, which is not at all available at all other places of t, will have a spectrum equal to 1. Just see the corollary. When the signal has a value only at t is equal to 0, like a spike, will tend to have its spectrum with a constant value 1 from minus infinity to plus infinity in the frequency domain, in the spectral domain. Very, very important observation. This is called a time domain expression, and this is called a frequency domain representation. This is called time domain representation of the impulse, whereas this is the frequency domain spectrum.